postdoc research associate in Harvard University. I'm going to present this project called Urban Plan AR, BIM Mobile Visualization in Urban Environments with Occlusion-Aware Augmented Reality. This work has been carried out in collaboration with LinkNode, a company based in Glasgow, in Scotland, as we do. And I would like to start with a picture to show the main idea of this project. As you can see on the tablet, the screen of the tablet, there is a virtual model, a virtual BIM model of a new building. As you can see, we are not just rendering our model, but we are dealing with occlusions. So we have, just in front of the model, there is a real building, which is there, and it's occluding our model. So, and after this, I would like to show you a video explaining the tasks carried out by the final user or the client. So you can make yourself an idea with the project. So first of all, the user is uploading the BIM model with the current state of the model to the cloud by means of a plugin in Revit. And then a second user is going on site and downloading that model and writing the tablet, and he can see the building, the 3D model on top of the real existing environment. Well, after this, and as an introduction, probably you may know, you are familiar with these kind of devices for visualization. There are different solutions we can use here. We can have Oculus devices, head-mounted displays, big screens, or even caves. But here we are kind of stepping back and using more simple solutions. In this case, tablet PCs. This is because this is helping us to deal with the first of the challenges. We can go outside and we are dealing with 6 degrees of freedom instead of 3. We are tracking, we are calculating position and orientation, not just orientation. Also, another challenge we are dealing in this project is that we don't want to depend on external devices or external signals, such as GPS or external features or markers. So we are relying only on onboard sensors, such as the camera, vision device, and IMUs in the device, in the tablet. Also, we want to integrate our system with another BIM software, in this case Revit. And finally, we want an occlusion-aware AR solution. So to get this approach done, we can divide our strategy in 2 different kind of processes. So we have an online process, which is divided into steps. First of all, we need to learn the visual and structural state of the existing urban real environment by means of a georeference 3D map of visual features and the creation of a 3D mesh of the environment. And the second step is to upload the BIM model to a cloud service and prepare it for visualization. Regarding the online operations, first we calculate in real time the location of the user in the environment, and then using that pose, we calculate the view of the BIM model, because as I mentioned, we are dealing with occlusion, so not the whole building is shown, but just one part of it. Concerning the first part, the first online process, you can see the pipeline of our work. First of all, we go there and we go on site and take some images. We extract the features, we create a 3D sparse point cloud and a map of features. And then with this 3D sparse point cloud, we create a dense point cloud and later a mesh. And then we apply the transform to the data, and we georeference both the map and the mesh, getting a georeference map and a georeference mesh. As an example here, you can see we go to the building, to the environment, we take some pictures, we create a sparse 3D point cloud, we create a map, then we produce a 3D dense point cloud, and finally we create a mesh. This mesh can be a problem for real time running and the tracking, because it can be too big, a lot of triangles there, so we can create a lighter mesh for a better tracking process. And secondly, we upload the BIM model to the cloud service. In this case, we are using an in-house built plugin for Revit called Urban Planner. So you select some features and you upload your model to the cloud. And regarding the online operations, first we are calculating the real-time position, localization of the user in the environment. There are three tactics, there are three methods there. First of all, we initialize the user inside the scene, and then when the user is being localized, we start the tracking process. And then if the user gets lost, we try to relocalize them by using the data, the history data, the last movements. This is some features and also IMU data. As you can see here in the graph below, as you can guess, the initialization process is more robust, but the speed increases during the tracking process. And well, the second stage of these online operations is to use this calculated pose of the user to compute the viewed part of the BIM model in the scene. As you can see at the bottom, we have the whole 3D BIM model, but in the big picture, we just see the top part and the roof because of the occlusion mesh. So this is the real view. This is what the user is experiencing with what he's saying, and you can see just the top part of the roof of the building. Sorry. These are some examples of the same environment but with different lighting conditions. The system is robust to these lighting conditions, and I would like to show you a couple of more videos. Where is it? I can click on the image. Yeah, click on the image. No, but I can't see the mouse.
Sorry. It's right there.
Alright, thank you. So here the user is panning and tilting a little bit the tablet, the first approach. So you can see that the model is following the user. You can see it better here. What? No. Still, sorry. Yeah, you can see now the user is walking, and maybe you can see, or no, there is scaffolding in the wall. There is scaffolding there, including the works. So, just to conclude, I would like to mention some values or some value of the BIM environment for our project, which is that we don't need to create again and again a 3D model, but we are using our very own 3D BIM model, and we can select the state of the model we want to show to the user. And regarding the value to the BIM community, the BIM environment, is that stakeholders can better understand the designs. Also, we don't need blueprints. We don't need to go to the office and turn on a big screen, and show them a virtual model. But we are going to the real environment, to the real site, and we are showing them the final result, or the assist at that stage. It's quite well. This project has been quite rewarding in terms of public engagement, because not only stakeholders but also the general public, we were testing our system on the streets, and they were coming and asking about the model we were showing there, and asking if this is the final result of the building in construction. So that's everything. Thank you very much. This is our website, and you can find there some of our current projects and previous ones. So if you can have a look at it, it's there. Thank you very much. Have a nice day.
Okay, thank you. It's a very interesting study.